Hi SQL folks, welcome to another free SQL Server content focusing on performance tuning. This demonstration, this tutorial, I termed this as funny. By the end of the demo, you would realize why am I calling it funny. In fact, all the stored procedures, the demonstration, I've named them as funny. And let's see why it is being called so. Now, what I would do is before I talk about today's subject, let's go and execute the stored procedure. This is probably going to take some time, and while it is running, we'll talk about a few things. So let's go and execute the stored procedure. Take a note that actual execution plan is turned on. So I'm going to execute this, and this is probably going to take a minute or two, maybe a little more. Now, what happens is when your workloads are running slow, you would put on your troubleshooting hat and look at a lot of different things. I'm randomly going to call out a few things, like you're going to look into the execution plan. You're going to look at the IO and execution statistics. How much time did it take? What kind of scan and seek was it doing? You're going to look at a lot of different numbers, the actual execution metrics. Inside the execution plan, you're going to look at expensive iterators or expensive operators and try to find out tuning opportunities there. You would go and look into the T-SQL as a whole and look at tuning opportunities. Is the T-SQL written the right way? Are you following good T-SQL practices? Are you avoiding those anti-patterns? And more specifically, inside the execution plan, you're going to look at all those indexes, the scans and the seeks, the sortability. Are you avoiding sorting, or is sort very expensive? Is it consuming a lot of memory? You're going to look at hash operations, and is there a way to minimize them or get rid of them? So many different things. You're probably going to look at all sorts of locking, blocking, and you're going to see if the query is being held up. Are there other processes that are blocking your own thread? So many different things. This query is still running. If you look at the execution time there, it is 1 minute 40 seconds now there in the status bar, and the query is still running. Okay, let it run. What we will do is let's copy this one and put it in a new window here. And I am going to look at the estimated execution plan. And when that is done, we'll go and look at the actual one also. So here I take up, I'm just running the estimated execution plan, which is we are not actually running the query. We're just trying to find out from SQL Server, hey, you know what the estimated plan looks like. And so there are no actual runtime metrics here. Let's right click and zoom to fit. So you have a decent sized plan here, and you're going to look at a lot of tuning opportunities in this one. This is estimated. So let's just wait for the query to complete. But as I said, all those things that you're trying to do, and why I term this entire thing as funny is sometimes we tend to overlook at the most basic things. There are settings inside SQL Server like min memory, max memory. You have settings like cost threshold of parallelism and so many different things. Sometimes we tend to overlook that. Do you have the best practices already implemented, or without even reviewing those, you are straight away jumping into the query and you're trying to tune it? Probably the query itself does not require any tuning. Maybe one of those knobs or switches or something that you might have overlooked, and it's important to keep going back into those things. Now the execution of the query is done. Here the execution is done. Just let's look at the number. This execution, friends, took 2 minutes 36 seconds. Keep that number in mind. So that's about 156 seconds. 2 minutes 36 seconds. And of course, as I said, you and I, even if I'm in your place, we're going to go and look into the execution plan. This is the actual execution plan, and you're going to see all sorts of numbers flying out there. You're going to look at merge join there, looks expensive out there. A lot of different iterators up there. All those scanning, spooling, seeking, all that is happening here. A lot of scans happening there. And And you would straight away jump into trying to tune the indexes, because you can see scans here, scans at almost everywhere, and then you have a lot of spooling also going on. So you would straight away jump, oh, that's the root cause. Let's zoom to fit this one, and this is what you got even in estimated, but now you have the actual metrics. Let's straight away come to the point. Let's park and keep aside all those tuning things that you would want to do, and let's review a few of those basic knobs and switches and the configuration settings at the instance level, server level, database level, right? Keep that in mind. Are those things done the right way? First and foremost, I'm going to take the cursor over the select operator. And this itself is just mind-boggling. The things that you get to see here is estimated subtree cost. Something is not right. Look at the estimated number of rows per execution. All this doesn't make much sense here, which means something could be terribly wrong. And this is why I use the term funny, because this is what we came across when we were working on a customer project. We were doing some performance tuning stuff on a specific server. Many of these workloads were misbehaving. It was not just one query or one stored procedures. There were a couple of them that were misbehaving. And the customer did say that sometime back they were not misbehaving, which means something has not changed at the query level. Probably something changed at configuration level, maybe hardware level, maybe instance level, something on the OS, something inside SQL Server. And as I said, if you look at the hierarchy, you have the server, you have the instance, you have the database. So something has changed there. And it's important to go and review all of those. Of course, in this demonstration, we don't have time to go through the entire list, but let's straight away come to the point. This is not making sense. And likewise, when we looked at other queries, we were getting all those absurd numbers. Take the cursor over the select operator here and you look at these. Now let's click here and go to the properties. When you go and look into the properties, this is something that we don't do quite often. Okay, let's admit this. You would go and look into a lot of properties of the other different iterators, but not really the select operator. You're always just good with taking the cursor over the select operator and looking at the memory grant or the estimated subtree cost and all of those stuff. But who goes to the properties window? But there you go. The moment you click on that select and go to the properties, and there is a reason why the cardinality estimation mode is selected there by default. I'll close that and right click and go to properties once again, and you have the cardinality estimated cardinality estimated model version selected by default. Let's zoom in and this will immediately catch your attention. For whatever reason, the cardinality estimator version is set back to the oldest version we can see, which is 70. That was set back in SQL Server 7.0 probably. So that's the old version. The newest is 130, which means either the database compatibility mode is not set correctly, or probably the database scoped configuration has changed. Something has been changed at the database level, which is making a set of these workloads run with the old cardinality estimator. What is this cardinality estimator? Now this requires a Google lookup and you should read more about cardinality estimator. In short, this is the piece of code inside the optimizer, which is responsible for doing estimations. When your query is sent to the optimizer is estimating the number of rows that is going to be produced by each iterator, which in turn computes and concludes that the overall number of rows that could be returned and generates an estimated execution plan based on the software code that is written in this cardinality estimator. And then that estimated plan is passed on to the query executor, and the query runs based on that plan, which gives you the actual execution metrics. that was a very high level overview of what this cardinality estimator is. It's more like a black box. Not much is talked about that, but there are a lot of transformation rules, optimization shortcuts and techniques, and whole lot of things inside this cardinality estimator. And the idea is Microsoft wants to improve this with each release, but that has not happened over a period of time. You had 70, and then starting from I think 2012 or 2014, you had the new version compatibility. The version number was 130. So 130 is supposed to be up there, but it shows 70, which is why all this nonsense is happening. It's because of this old cardinality estimator. In one of the latest versions of SQL Server, you're getting such poor performance out of this query execution is because in one of the latest versions of SQL Server, you have a workload that is running with one of the oldest pieces of code, which is cardinality estimator 70. And that's why you're getting this poor execution performance. Funny stuff. There's nothing wrong with the query. There's something wrong with this setting that is done on the database. So let's go and look at the compatibility level. This is AdventureWorks 2016. I'm going to right click AdventureWorks 2016, go to properties, and first things first, I'm going to look at the database compatibility level. Let's go and check that. We click on option, and you know what? The database compatibility level is set to 130. So why is SQL Server resorting to the old cardinality estimator? Which means probably a alter database scoped configuration query has been run, or something is changing before these executions are happening. And I did that for the demo. Otherwise, what we saw on the customer side was this is what was happening earlier, right? So you could look at the compatibility levels here, right? Starting from 2008, 2012, 14. Look at the different versions there, the compatibility level. So let's go and change that scope configuration, and you can find this out by, let me go and look into the query. Here I have this piece written there, and I created this funny stored procedure. So alter database scoped configuration. Okay, first let's go and okay, so this is on. Let's turn this to off, right? Okay. Of course, I just engineered this and I wanted to show this, so I turned it on. So what I'm going to do is look at this statement here. Alter database scoped configuration set legacy cardinality estimation, and I'm setting it to off, which means someone turned it on, or the database compatibility level was set to a prior version, and that was resulting in a lot of these workloads being regressed, right? Poor execution. Let's turn it off. And let's revert to the most recent cardinality estimator version now. Go back here. Let's go and execute this, and let's see how much time this takes. So earlier it took 2 minutes, 36 seconds. We'll go and execute, and this runs in less than 1 second, right? This is what you want. And of course, you're going to get a different execution plan. Let's go and turn on the actual execution plan. Let's go and execute this. Job done in less than 1 second. Go to the execution plan. You of course get a different execution plan, but I am just not comparing it here right now. But it is important. Yeah, of course, here, this one, right? If you look at the subtree cost and estimated number of rows per execution, now this makes a lot of sense. Earlier, you were getting all sorts of nonsensical numbers. And of course, let's review this. Let's go to the properties and see the cardinality estimation model version is now set to the latest, which is 130, and that does the trick. Which means, friends, very, very funny thing, right? Funny piece of demonstration, funny piece of tutorial, but these things do happen, and this is where you learn and you have real life experience where you see that sometimes there's nothing wrong with the code or the database or indexes or anything for that matter. Is just one setting, is just one configuration option in those multiple layers, server level, instance level, database level, that just needs to be tweaked around, that just needs to be changed and can make dramatic performance improvement. Hope you've enjoyed this demo, funny demo, but yeah, lots to learn. Friends, don't forget to review the masterclass recordings of the recent performance tuning class that I had delivered. The recordings are now available. 40 hours of deep dive content. And once you subscribe, you get lifetime access, which means you can watch the content anytime, anywhere, as many times as you want. Just hop onto SQLmaestros.com, look for the performance tuning masterclass recordings, lifetime subscription. All right, friends, we'll see you soon in another demo very soon. And another quick reminder about our upcoming webinars and content. Yes, so right on SQLmaestros.com, check for live webinars, free webinars. And each Thursday, I am delivering webinars back to back. And that's absolutely free for the community. Feel free to join, and hopefully you will learn something new. Happy SQL.